first, I'm going to represent my polynomial using the algebra tiles. So here, where it says 2x squared, to show that, I need 2x squareds. To show 3x, I need 3 of my x algebra tiles. To show plus 5, that's 5 ones. Now here I need to be a little bit careful because I have minus 3x squared. That means I need to use my red negative algebra tiles. So minus 3x squared means the same thing as 3 negative x squared. So here are my 3 negative x squared algebra tiles. Then I have plus 4x, so that's going to be 4 of my positive x tiles. My last term is minus 9. Since it's a minus, I need to use my red negative 1. So minus 9, I could think of it as the same thing as negative 9. So I'm going to show 9 negative 1 tiles. 6, 7, 8, and 9. Now in order to simplify this, what I need to do is combine all of my algebra tiles that are the same shape and cancel wherever I can. So I'm going to start with my x squared algebra tiles. If I line up this positive x squared and this negative x squared, if you remember what we said earlier, these two are going to cancel each other out. When I add them together, I get 0, which makes sense because x squared minus an x squared is 0. So I'm going to go ahead and delete these because they have canceled. The same thing is going to happen with these two, this positive x squared and negative x squared. Those two make what we call a 0 pair, so those also are going to cancel one another out. So the only x squared tile I'm left with is this 1 negative x squared. Now I'm going to work with my x's. And when I combine all of my x's together, I don't have any negatives, so none of them are going to cancel, but I can just put them in one group. So I don't need to have one group of 3x's and a separate group of 4x's. I can put them together and say, well, I just have 7x's. The last thing I'm going to look at are my 1s. And here I've got 5 positive 1s. And I have 9 negative 1s. And I'm going to go ahead and line them up. So I'm going to match each of my positives with a negative because I know those are going to cancel and make 0 pairs. So it looks like I'm going to have 5 0 pairs. Then I'm going to have these 4 negative 1s left over. So when I delete all of these 0 pairs, because they all cancel, all I'm left with is the simplified version of my original polynomial after I combine like terms. So when I combine like terms, my final simplified version is going to be negative x squared plus 7x minus 4. And that's the simplified version. Subtracting polynomials is very similar to adding with one exception. And when we subtract, it's useful to think of subtraction and the subtraction sign as actually meaning the opposite. So what I want to think of this as is that I need the opposite of my second polynomial. So I'm going to take my first polynomial, 5x squared plus 8 minus 4x, and I want to combine it with the opposite, which is what that minus sign means, of my second polynomial, 12 minus x squared plus 3x. So I'm going to start out with my 5x squared. Plus 8 minus 4x. Oops. And now I need the opposite of my second polynomial. That means if I started out with 12, the opposite of that is minus 12. So I need to show minus 12, 1. 1, 2, 3, 4. Oops, there's my minus 12. My next term is minus x squared. Well, the opposite of minus x squared is positive x squared, so that's actually going to be one of these. And then I have 3x, but the opposite of 3x is negative 3x. Once I have this set up, I can combine like terms, cancel where I can, and then have my answer. So I'm going to put this x squared over with my other group of x squared. So altogether I have 6x squareds. I'm going to combine all of my negative x's here. So altogether that's 1, 2, 3, 4, 5, 6, 7 negative x's, or minus 7x. And then I'm going to combine my 1's. And I'm going to have some 0 pairs. So here I've got 8 1's and 8 negative 1's, and all of those make 0 pairs that will cancel, so I'm going to delete those. So all I'm left with when I'm done is 6x squared minus 7x minus 4. Oops. So this is my answer when I subtract those two polynomials. Now you're probably thinking, gosh, this takes a while, and I don't always have algebra tiles with me, so it's helpful to be able to do these without algebra tiles. And that means that I'm going to need to take the opposite of everything in my second trinomial. You could also think of it as distributive property, and what I'm basically doing is distributing the negative, or distributing the opposite, to each of my 3 terms. So I'm going to rewrite what I have after I do that distribution. Well, my first binomial here, 8x to the 4th minus 2x cubed, isn't actually going to change. It's not affected by that opposite sign, that minus sign. When I distribute my opposite sign, 12x cubed becomes negative 12x cubed, or minus 12x cubed. Negative 6x squared becomes the opposite of negative 6x squared, so it becomes positive 6x squared, or plus 6x squared. And negative 3x becomes the opposite, which is going to be positive 3x.